What I'm going to present today is not just one project, but a series of projects that involve multiple people at multiple locations. The NRI provide information on status, condition, and trends of US lands. This large data set, as we've heard from all of our previous presenters, provides a quantitative way of addressing diverse research questions too. The scale at which these data are collected allows for a statistically valid way of scaling research up to regional and national scales. In this talk, we highlight multidisciplinary and multi-institutional research that use NRI as well as some AIM data. The first example is the range analysis platform. Shane Green talked about this earlier, so I won't go into much detail. This is a free online tool that enables landowners and resource managers to track vegetation through time. It uses the Google Earth engine to merge machine learning, cloud-based computing, remote sensing, and field data to provide annual vegetation cover maps of rangelands and rangeland vegetation in the US. It uses over 60,000 field plots across the USA. And I should have been switching these. So the mapping technologies used with the rangeland analysis platform allow people to view trends in rangelands through space and time and scale, which is one of the great things about this effort. Another effort currently using NRI data includes the USDA ARS and collaborators who continue to build a broad land potential knowledge system, or land PKS, which integrates data from NRI, the BLM's AIM, and land PKS itself to fill in gaps in field data coverage and further improve research predictions, such as those generated by the rangeland analysis platform. The land PKS is available online or through a free mobile app, and you can use your mobile device in the field for soil ID, land cover measurements, soil health monitoring, land management, farm record keeping, and much more. So this is the land PKS website and access to where you can access it through the mobile app too. So, another effort includes USGS, BLM, and other collaborators who are developing ecological site group concepts for the Colorado Plateau and Upper Colorado River Basin using digital soil mapping approaches. The NRI and BLM AIM data are linked to these ecological site groups spatially and are also being used as part of data-driven state and transition model development approaches. The USGS in Moab, Utah has also been working in collaboration with Jornada in southern New Mexico to curate USGS, National Park Service, BLM, and NRI monitoring data for application to remote sensing tools and products. One of these products is Landcart, which is a NASA-funded project in which BLM, USGS, UCLA have created an on-the-fly cover estimation tool trained by data from BLM, NRI, and National Park Service. The USGS is also working to refine an existing invasive grass mapping tool for mapping annual grasses across the Southwest based on phenology. Both of the USGS-led efforts use NRI data, National Park Service data, and BLM data to train and validate their models. There's another effort going on led by Dr. Sarah Gossley at the Pasture Systems and Watershed Management Research Lab in University Park, Pennsylvania, who is working on a species distribution and abundance modeling project that will use NRI as training data and machine learning models of potential species abundance. The model predicts potential plant abundance on a site type, uses machine learning models that use climate, soil, topography, and different variables that affect plant available factors such as soil moisture, and can be incorporated into ESD development and decision support tools. Another research project that is using NRI data as well as AIM data. It involves the Jornada and the National Wind Erosion Research Network, who are looking how to add value to standardized monitoring data sets like the NRI by developing new tools to predict indicators of wind erosion and air quality. The Aeolian Erosion Model, also referred to as AERO, leverages these NRI-derived estimates of bare soil, vegetation height, canopy gaps, and canopy gap distribution to predict potential horizontal and vertical sediment mass fluxes at NRI and BLM AIM plots. The Jornada is also developing the Landscape Data Commons, and this data commons aggregates standardized monitoring data sets, such as the ones we've been talking about today, BLM AIM data and the NRI data, and also use data from the USDA National Wind Erosion Network and the LTAR network, the Long-Term Agroecosystem Research Network. The data common uses an R package called Pterodactyl to aggregate these data. It calculates indicators, produces inputs for erosion prediction models, like REM or AERO, the REM being the Rangeland Hydrology and Erosion Model, and connects indicators and model outputs to interpretive tools like the ecological site descriptions and in EDIT, which is the Ecosystem Dynamics Interpretive Tool. A lot of acronyms going on in this presentation. And the goal of the data commons is to make standardized monitoring data sets like NRI more accessible to agencies and collaborating scientists. The graphs here show a selection of NRI indicators for 2 ecological sites in Major Land Resource Area 42, and are modeled wind erosion responses and how they change to indicators across different ecological states. So the goal here is to include summaries of calculated and model indicators from NRI and ecological site descriptions and ecological site groups so that users can assess the condition of their land. This is intended to help managers ID benchmarks to support land health assessments and to determine which conservation practices could be most effective for avoiding transitions to less desirable states. There has also been discussion among USDA Natural Resource Conservation Service biologists about larval and nectar food resources available to monarch butterflies and on non-federal owned rangelands, and how changes in some of these resources might have an effect on butterfly spring migration patterns. So Ken Spaeth, with others, took about 2,000 NRI rangeland sites with milkweed presence where track those milkweed species densities, look at geolocations and environmental gradients where these milkweeds were present, and analyzes all these environmental variables to show that the different species present in the different areas, but also one of the interesting things that came out of this were the environmental variables associated with presence of milkweed, which was a dominance of mollisols, non-saline sites, neutral pH, well-drained soils, usually on loams and sandy loam textures, and sites where organic matter was somewhere between 1.5 and 3%. So as you've seen, there's a broad range of different uses of the NRI data. In addition to providing information on status, condition, and trends of U.S. lands, the NRI data are large data sets with potential to address many diverse research questions. This presentation provides a broad overview of what is being done by some people, but much more is possible and much more is being done that I am not reporting. I just reported what I know of and what some of my collaborators are doing. One of the great things about these long-term data sets is that they allow us to make projections and simulate different management scenarios and actions through time. Leveraging these NRI data with other larger data sets, as we've seen with AIM and some of the National Park Service data sets and Land PKS and these other data sets, allows us to provide a more integral stewardship approach that reaches across boundaries, disciplinary boundaries, but also land boundaries, and allows us to better manage resources across wider landscapes. And last but not least, all of these efforts depend on having good data and good data management. Many of you listening here right now have collected and will continue to collect and manage these data. So please realize that the impact of your work is huge and the importance of doing it well. All of these efforts are worthless if the data that we used to create and validate these models and the data that we're collecting is not good. So thank you very much.